NeuroSafe Medical Corporation Limited was established in August 2016. It is located in number 2, Gangwon Park, Zhuhai High-Tech Zone. It is a high-tech enterprise focusing on manufacturing medical device for stroke solution. Through several years of technological innovation, accumulation, independent development, products could be continuous iteration. The company possessed a set of development and production technology of neurovascular intervention products, range to Class 3, and own independent intellectual property rights. Our main products include ischemic, hemorrhagic, and access products, Liquid Embolic System, Dredger Revascularization Device, Renova Detachable Coil System, Glutton Aspiration Catheter, and other catheters, etc., were developed independently. Renova Detachable Coil Systems is generally used for intracranial aneurysms. Firstly, push the microcatheter into the targeted aneurysm. Draw back the micro-guiding wire. At the proximal of coil system, 10 cm breakable zone configured to push the shaft. The push shaft is a stiffness and gradient structure, coil equipped on the distal end of push shaft, which makes sure it could be smoothly delivered and greatly minimizes kickback microcatheter. Before use, please check the coil system. Firstly, check whether it is broken or not at the proximal zone. Take the coil out. Bring the coil out of protective sheath and check the coil and detachable zone. 3D coil has good performance for frame due to the softness. If there is no problem, secondly, withdraw the coil into sheath again if there is no broken. Insert the sheath into the YRHV, reaching half the length of the YRHV, and rotate the YRHV tightly. Flush the sheath with a high-pressure infusion set. Until the saline overflows from the proximal end of the sheath. Loosen the YRHV and continue to insert the sheath into the hub of microcatheter and then fix and rotate it tightly. Push the sheath into the microcatheter. Make sure the distal segments of protective sheath and microcatheter is closed tightly. Otherwise, the coil will be possible to be damaged at the distal part of the microcatheter. Push the shaft smoothly. Deliver the coil into microcatheter. Loosen the YRHV and withdraw the sheath from YRHV. Then tighten the YRHV properly to prevent blood backflow. Continue to push shaft smoothly. Two markers located at the proximal end, 145 centimeters, 155 centimeters from the distal of push shaft separately, would indicate that the coil is about to reach the targeted aneurysm under fibroscopic guidance. If the coil does not have frame well, it can be withdrawn and then released again. When the marker of guide wire and proximal one of microcatheter are moving like a T-shape under fluoroscopic guidance, the coil can be detached by breaking the zone of shaft. Then pull the wire gently. The movement of detaching marker is visual under fluoroscopic guidance. At the same time, it can be felt that the load force released suddenly. Withdraw the guiding wire slowly. Coil detached and released successfully. Then withdraw the wire from the microcatheter quickly. Continue to use excess coil as above steps until the expected filling effect achieved. The The distal hardness of aspiration catheter is gradual, enhanced support and torqueability at the proximal, comparable with 6F long sheath and 8F guiding catheter. 0.072 larger lumen. A guiding catheter or a long sheath is placed. Take the aspiration catheter out from the dispenser. Check if the catheter with defects such as kink, tip collapse, deformed, etc. Soft tip. Hydrophilic coating on the outer surface of the catheter is very lubricated after activated. Loosen the YRHV. Push aspiration catheter through guide catheter. Push the microcatheter, which matches the revascularization, in. Pass the thrombus under the guidance of the micro-guiding wire. Then remove the micro-guide wire from microcatheter. The push wire of Dredger Revascularization Device is made of nitinol. It is super elastic. No worry that kinks and delivery problems occur in the procedure. Soft wire coiled tip at the distant end of the revascularization device prevents vessel wall from perforating and injuring. Distal tuck nets avoid broken small clots running away. Varied grid cells designed for engaging and clamping clots captured in low radial outward force, mainly due to clamping of grid cell changes. Insert the sheath into the half position of the YRHV and rotate it tightly. Flush the sheath with a high-pressure infusion set until the saline overflows from the proximal end of the sheath. Loosen the YRHV and continue to insert the sheath. Push the revascularization device into the microcatheter. Remove the sheath. Continue to push the revascularization device at the position of 1,450 millimeters from distal. 3 markers on the push wire to remind physicians. Withdraw microcatheter and release the revascularization device at the clot's position. Process angiography to confirm the right location of the clots engaged with device, and check blood flow at the distal is smooth or not. Install torque device on push wire next to YRHV, which connected to microcatheter. Withdraw the microcatheter from aspiration catheter while perform negative pressure aspiration. Continue to withdraw the microcatheter. Until the retriever basket net reaches to the YRHV. Remove the YRHV. Aspirate again with syringe. Remove the clots from catheter. Perform angiography to confirm whether the flow restored. Remove the catheters after procedure completion. LAVA, the Liquid Embolic System, was produced by NeuroSafe Medical Co. Limited. It consists of a vial of LAVA liquid embolytic agent, a vial of DMSO, and 3 syringes. The LAVA liquid embolic agent in 3 viscosity formulations: LAVA 12, LAVA 18, and LAVA 34. Blue syringe used for injection DMSO, and other white syringes for liquid embolic agent. Push the microcatheter into the AVM following the guide wire. Then remove the micro-guiding wire. Confirm the tip position of microcatheter by angiography. Flush the microcatheter lumen several times with saline. Do not remove the syringe after flushing. Aspirate about 0.8 milliliters of DMSO with blue syringe. Then remove the saline syringe from the microcatheter. Connect the DMSO syringe to the microcatheter. Fill the dead lumen of microcatheter with DMSO sufficiently. Keep the DMSO syringe connected to the microcatheter after filling. Aspirate liquid embolic agent with white syringe. Remove the DMSO syringe from the microcatheter and fill the hub of microcatheter with the remaining DMSO. Keep the hub of microcatheter vertically. Then connect the embolytic agent syringe quickly and flip 180 degrees quickly in order to form a liquid layer between the embolic agent and DMSO. Keep the syringe vertically. Inject liquid embolic agent slowly at a rate of 0.16 to 0.3 milliliters per minute. Replace DMSO in microcatheter. When the layered area enters into the microcatheter through the microcatheter hub, it can be changed to a comfortable position. Continue to inject at a rate of 0.16 to 0.3 milliliters per minute. Injection into arterial venous malformation at intervals by suitable frequency until an expected embolization effect is achieved.